So, this time we have done some basic stuff. We have interacted with our website through some custom code, but we haven't really touched like the important aspects of an application where there's some user input that is actually persisted or modifies the state of the application. So how do we interact with data in the database? Let's look at it. So the next thing we're going to create is the next thing we're going to do is kind of a bigger task. We're going to create some definitions for the database, what kind of information you want to store, and we're going to create some ways for the user to be able to actually add some input, which will be persisted to the DB. So let's go ahead and create. No, actually, we already have this folder. So we have models here. This is basically coming from the MVC convention. So you have views, models, and controllers, or actually models, views, controllers. That's MVC. In Orchard, one of the conventions is that the types of information or the classes of denoting some information you want to store are also going to the models folder. So let's create a new class to represent the information we are going to push to the DB, and let's call it person record. So person record, and records is one of the way of storing information in Orchard. Well, since it's using a relational DB by default, or actually kind of a hybrid relational and the document database by default, but you can use document DB in Orchard core. So records is one of the ways to store information. So person record is going to be a very simple class that is going to tell Orchard that there's some information that can be described as a person I want to store in the database, and of course I need to access it programmatically, so I need a class for that. So let's say first, since we are talking about relational databases, each record has to have an ID. So we are going to use we are going to add an ID property, and it's going to need to be virtual. This is basically part of the API because Orchard uses nhibernate as the object relational mapping library. So basically the ORM is a library that sits between the database and the application. So it gives you an ability to map database, well, not particularly objects, but data sets coming from the database can be mapped to actual classes and instances of classes inside your application. And one of the important things to note here is that there are some restrictions what you can do in a case like this. So you need to be aware of the database engine you are using, because it actually restricts you what kind of data you can store in the database and what kind of property types you can use in your records. But integer, we are using SQL-C in this case. If you are running an actual Orchard application, you would probably use SQL Server. There are some other cases. Orchard 1 also supports I think Postgre and MySQL. Orchard core, which is the ASP.NET core implementation of Orchard, will have support for other database types as well. But when you're actually figuring out the data structure you want to represent in a database, you need to be aware of the database, the underlying database. Of course, the role of the ORM is kind of to be an abstraction, because in the end you are really interacting with the ORM, so it should make your life easier. So you don't really need to care about the database, but you still need to care about the database in a way that you can do everything. But the ORM is there to abstract these things away for you. So we are not really going to write SQL, for example, SQL scripts, because we are doing everything programmatically and use different types of APIs and abstraction layers that are making our lives easier, except when they are making our lives harder. But that's another case. Sometimes they are making our lives harder, but the aim is to make it easier. So this person record class in the end will be mapped directly to a table in the database. First, we need to figure out what kind of information we want to use. And like I said, every record has to have an ID property. And there are some other properties as well, which we are going to implement in a moment. Okay, so let's continue adding some properties to our person record class for us to be able to persist some data into the database. The next property a person might have, which is quite surprising, is a name. So let's add the name property very quickly. Is string, no, I said, yeah, oh, okay. Actually, it's virtual. Yeah? So public virtual string name. The next one is public virtual, and we're going to use an enum here. We're going to declare later to store the sex of this person, and we're going to add an enum. I'm not sure, but oh, okay, come on. So I'm typing quite quickly and making interesting mistakes. But you know, this is still quite simple. The next thing is the birth date, which should be a date time, except that it's generally best practice to add date times as a nullable property. And the reason for that is otherwise you will have a default value that may not be compatible with the database. If it's nullable, then it's going to be null. If it's not provided, and you know, null is probably supported by any database engine. Otherwise, you might run into a problem that, let's say you have a default value of the date time in .NET, but if you want to persist that into as a default value into a specific database engine or something like that, it may not be a valid value. It happens sometimes, or it can happen. And another best practice to take note here is UTC. So in general, actually, when you set up an Orchard application, it's going to set the time zone to the operating system's time zone. But you can't really expect every one of your users to use the same time zone. Of course, Orchard can handle these kind of things, like how to display or how to display dates and times according to time zones. So that's not a problem. But as a general convention, it's useful to store every piece of every date time in UTC. So whenever you fetch that data, you can always convert it to the relevant time zone of your user, to your user's relevant time zone. So you don't mess up something like, okay, my application, when I first deployed it into some data center, is on the US East Coast, so it's UTC minus 5 hours, so I'm going to store every date time in UTC minus 5 hours. Okay, let's, I don't know, expand the reach of my application and let's put it into an Asian data center, which might be UTC plus 4 or 5. So you don't need to keep track of all these. If you store everything in UTC, then you have a common denominator in some terms, and after that you can always convert it into a different time zone according to your users or the location of the application or whatever makes sense. So always store UTC. Okay, next step is just to store some textual information about your users, which will be biography. So it's going to be, I can't type. If so many people are watching, especially those on YouTube or whatever. So this is going to be biography. And we're going to use another piece of API here, which is string length max. and it's in the orchard.data.conventions namespace. Let's take a look at what happens here. If you use the string length max attribute, you're basically telling the ORM that the string that you want to store should be larger than expected by the database. So I think in SQL Server the varchar is some huge, well, not particularly huge, but like a big string that usually enough for like general data. There's another step of 2,000 characters. If you are using the string length max, also very hard to say, attribute, then your string can be 10,000 characters long, which is larger than mvarchar. So we have this biography property as well, and let's just say that we're going to initialize the value of biography. So if you don't define a biography, then it's going to have some default value. So we're just going to say that by default the value of the biography should be there is no biography for this user yet. Okay, so now we have our person record class. This is going to be the application side representation of the pieces of data that we're actually going to store in the database. And now let's go ahead and look at another piece of the Orchard API, which is very important, which is called migrations. So for this, I'm going to create another solution folder. Now we are slightly off the track. What you might see from the training demo module, this is going to be a slightly tidier, so to say. So I'm just going to say I'm just going to create a solution folder called migrations, and I'm going to say that I'm creating a class called person migrations. So what is a migration? Migration is basically a concept where you can define what kind of changes should be made to the database schema. This is the place where you define that I want to create a table with this and that columns, which will be the database side representation of the data that we have just defined for the server side or the application side for persons. So this is where we are actually going to create a table, or actually tell Orchard through a specific piece of API that you should go ahead and create a table. We are not going to write SQL scripts here because Orchard has a lot of abstraction layers. It has a million different APIs for a million different things, and one of those is actually, or actually many of those are to communicate to the database some schema changes. But we are not really writing SQL scripts. We have some nice fluent interfaces. So the first thing we need to do here is whenever we have a migration, we will inherit this class from the data migration IMPL class, which is living in the orchard.data.migration namespace. And yeah, there are some properties here that we are going to use, or actually for this time we are going to use the schema builder. So this is this gives us a fluent interface to define some database schema changes. So now we have our migrations class, but we need to figure out how to communicate Orchard changes to the schema, especially if we want to evolve our code and our functionalities, and on top of what we have done earlier, we want to make further changes. So let's look at what happens next. The first thing we need to do, and this is an Orchard convention, is the method called create, and it returns a value of the type integer. And it doesn't have any input parameters. And just for the warning to go away, we're going to say return 1. Why are we returning 1, you might ask? Well, the reason for that is because this particular migration has been created, and when it runs, it should be at the version 1. So when the create method has done its job, then we are at the version 1 of these particular migrations. And the reason for that is we should have actually the CQC toolbox here, if I'm going to find it. Actually, I'm not really using that particular extension. Oh, okay, we have it here. Awesome. So I'm just going to attach it to this side panel. Well, okay, this is fine as well. Okay, much better. So I think we're going to need to add the data connection here. So add SQL Server Compact 4.0 connection. And for the file name, we are going to browse to the solution. So we are going to open up the root of our application, go to src, orchard.web, add data, sites, default, and this is the same default, the same kind of reference that we have seen in the error log before. This is the name of the tenant, which is a term from multi-tenancy we're going to discuss later. So we're going to open up default, and as you can see, we have a single orchard.sdf file, where there's other files here, but this particular browser only cares about database files, SQL Server Compact database files, which always have the SDF file extension. So we're going to open up orchard.sdf, and maximum database size 256 is fine. This database is much smaller than that. We don't really need the password. Unless, yeah, connection is okay, and this is the route. So this is just the path to the file, and the connection string is quite simple. So data source equals file path, very simple. So let's hit OK, and now we're going to have a connection established to our database file, and we're going to take a look at why migrations matter and what it does. So first of all, to understand what we're going to do, we're going to take a look at other migrations as well. So if you scroll down, not so much, but if you scroll down to somewhat before the middle, you will see some tables that start with Orchard Framework. So now that we are looking at the database structure as well, we can just very quickly discuss what's going on here. So if you have your custom code, you can create as many tables as you want, but the naming convention is kind of predefined in a way that your database tables will always have the name of your feature at the beginning, or the name of your actual module name at the beginning, with the dots replaced as underscore characters. And after that, you will have the name of your class, so without the migrations. So, or actually, that's wrong. That's inside the data migration record class. So that's something that's different. So basically, what you have here is feature names like Orchard, AutoRoute, and then some table names like AutoRoute part record. AutoRoute part record is basically very similar to what we did before with our record class, but the AutoRoute part record is actually defined inside the code. But Orchard.AutoRoute is basically automatic. So if you have a migration class inside the Orchard.AutoRoute module, then the tables created in that module will always start with Orchard_AutoRoute. After that, what happens after that is up to you. So we have a bunch of tables representing different data structures coming from different modules. You can take a look at them. They are quite interesting, but we will look into other aspects of the Orchard API and we will discover maybe some of them. But we can look at the data migration record, or data migration record, however you want to call it. And let's say that we want to, let's say, yeah, for the simplest thing, open the top 200 lines or top 200 records for editing, but we're not going to edit them, just take a look at the values. So as you can see, since we have data migration record, we have a data migration record class, so it's easier to understand what's going on here. So this is a record as well, what we did with person. It also has an ID because it needs to have an ID. and it has a string property with the name data migration class, and a nullable integer for version. And if you take a look at the table, what you will see is that it has an ID, it has a data migration class column and a version column. So pretty simple, okay. If you order it by data migration class, you will basically have a nice ordered list. And what happens here is that whenever you have a migration class with a create method, Orchard will pick it up because it will take a look at every implementation or every class that inherits from data migration IMPL. It will specifically look at create methods, and there are other methods we're going to take a look at soon. It's going to take at create methods, and if it doesn't have a record here in this table, in the Orchard framework data migration record class table, then it's going to create one and look for a create method. It will execute that, and if it runs successfully, an entry will be added here where the version is 1, or actually where the version is the same number as what the create method returns. But by default it should return 1. You can say 100, and then after that you need to write a method with a specific name to be able to make changes built on top of that inside the same migration. But we will take a look at that soon. So we have our create method. Let's just care about the create method. We will do some database changes and return 1. And we will tell Orchard that, hey, I have this new module here. I have this migration class here, which inherits from data migration IMPL. So you should really take a look at this thing. And then Orchard says, yeah, hey, yeah, I know you have a create method. Yeah, nice stuff. I'm going to run this code. Yeah, here's your table. Very cool. Yeah, I see you returned once. I'm just going to put the value 1 into the version column of your new entry in data migration record, and we're done. If for some reason the code can't execute because there's some error, or maybe you want to create a table that already exists, then you will get an exception and that transaction will be rolled back. So the changes will not be persisted. The migration won't be successful. If it's in the create method, I think it will create the entry either way, but with a version 0. I think doesn't really happen to me. I think so. I'm not 100% sure about that. But the main thing is that it won't run, and Orchard will detect that I have a migration that I couldn't run previously. So whenever your application is restarting, it will always try to load and execute the migrations. So if let's say you made some changes to that migrations create method to fix the problem, then you hit save, dynamic completion kicks in as you hit refresh in the browser, then Orchard is going to pick up the change and try to execute the migration again. It might fail again, and then you make some changes again, and this goes on until you fix the problem for real. So, first things first, we have the person record class. Let's create a table to represent the same data on the side of the database. So we are going to use schema builder for that. As you can see, it's of the type schema builder. So if we hit dot, we are going to see a bunch of things that we can call on this object. One of the things that we can do is create table. So that's what we care about right now. There are some other things you can visit or try out. For now, we only care about create table, but of course we have alter table. So if you want to add additional columns later on, or you want to delete a table from the DB, you can also do that. Or actually, I told you that we're not going to write SQL scripts, right? We're using some nice abstractions and APIs, but you can actually execute SQL scripts on the database. There are some cases where it might be easier if you have to fix something and the API gets in your way, then you might want to do that. But as a general principle, you should always use the API because it has the built-in abstractions necessary for your purpose to be fulfilled for real without making any mistake or deleting or creating something that shouldn't be here or should still be there. So yeah, we're going to use the API. So let's say we're going to create a table. First parameter we need to pass on is the name of the table actually that we're going to create, and there are some other things as well. Okay, so let's create a table for real. I just talked about it, but let's do some useful stuff. So the name of the table should be, well, usually it should be the same as a record class, or when you're actually creating a table to specifically match a record class, it should be the name of the record class. And the nice way to do that is to not to write it as a string like person record. It's actually nicer if you use type of, which is a built-in keyword, person record, and we need to add it as a using .name. Or actually, if so right now we are using C#, every language feature up to C#5, but if you are writing C# syscode, then what you can also do is to type name of person record. So it's kind of a shorthand for type of person record.name, and it's easier. But right now, due to dynamic compilation, we are restricted to C#5. So what's the next parameter? So it's going to be a lambda expression. So as you can see, we are expecting an action of the type create table command. So what happens here? Actually, I usually follow a slightly different kind of structuring to the code. So what we are using here is that we have a create table command, and we can basically chain different methods because it's a fluent interface. We can chain different methods onto this create table command to do what we want to do, and basically we aim to create columns inside this this table. And each of those columns will be a direct representation of the properties in our record class. So the first column we're going to add, and with this there's two type of two overloads we can use. One of them is just a method where we can actually define the DB type. As you can see, it's this parameter to be represented. We are going to use the other one because it's easier, which uses a generic. So we're going to say column int because the first parameter or first property we need to store is the ID. So we can actually say this time we need to type it as a string because we are, as like I said, we are restricted to C#5. But if you are writing C# syscode, you can actually say name of person record, or actually you wouldn't do it this way. You would say name of ID if you have access to a person record object. But anyway, so we have to write ID. That's the most important thing right now. And in this case, we also have another Fluent interface, but as you can see, it's not a create table command, it's a create column command this time. You don't necessarily need to define it, so it's optional, but this way you can actually define additional settings for the column. And in this case, we need to say that this is the ID that actually identifies this this record, so it needs to be a primary key, okay, and it needs to be an identity. So, you know, it can't be the same twice. It can't have the same value twice because that would mess up everything, and then you're basically facing some terrible inconsistencies. Oh, actually, I forgot to add name here. So if I were to stop here and run the code, there would be a table created with this ID column. But let's go ahead and create some more columns because we have more properties. So very quickly go through them. The next one should be a string of the name name. And let's say that we are restricting the length of the value inside this string-based column to 500 characters, and the way to do that is to use this lambda expression and say with length is 500. Actually, if you only define this on the side of the database, because right now we are actually defining restrictions on this table, or actually the column inside this table. If you don't apply the same restriction on the server side, for example through validation, then you will definitely face problems if you want to save more than 500 characters. But I think it's safe to say that a name shouldn't be longer than 500 characters, even if you are in a Brazilian soap opera, so you'll be fine. The next thing is to store the next property, and for enums we need to store them as strings. So nhibernate will take care of the rest, and when we are pressing this value on, it will be a string. So the database won't really know. Well, SQL Server doesn't know about enums, so it doesn't care. What the hell is this? They need strings to work with, but when the data comes back, then actually nhibernate will take care of it, and it will be an enum when we are working with this value on the application side. So let's create that one again, and we don't need any configuration for this one. And the last one is also a string, but it's the biography. And we are also defining some settings, and it should be column.unlimited. So like I said, if you have some inconsistency in the configuration of how you define your data structures, then you may have some problems. Now we have the unlimited basically tells that it can be unlimited. But we also have this defined on the application side, so we won't really face any problems because there won't be any inconsistency. With the name there might be, but like I said, we don't care about this right now. It's not that important. So let's just close this, and also this section as well. So it's really nice. Now we have some code to create a table, but let's say that we want to run it, and actually we will make some modifications to it to see how to build on top of your own changes. So I'm just going to clear out the usings, and hopefully if I hit Ctrl+Shift+S and reload the page, then dynamic compilation will kick in again. The application will restart after a successful dynamic compilation, and as the application is reloading, it will actually notice that there's a new migration class in town that needs to be executed, and it has a create method, which is nice because it's according to the convention. It has some code inside it that creates a table, and hopefully we have a successful execution. And yeah, actually I'm going to clear the log files, so if there's a problem we will notice immediately by new log files being created. So if we come back to the SQL Server Compact Toolbox and the refresh, probably this one, yeah. If we go back to tables, what we should see is that we have, oh yes, okay, I was worried for a second because I didn't see that first. But now we have Dojo Course 2 _ module. Like I said, this actually corresponds to the name of our module, which is called Dojo Course.module. And we have a table called Dojo Course _module _person record. So I have defined that I want to create a table called person record. This is what it represents, and it will be prefixed with the name of my module. And that's the actual name of the table that is being created, or actually has been created, with the dots replaced with underscore characters. So nice, we have a table. That's really cool, right? We can actually do some funky stuff to store data. But let's say that if we go ahead and start working with our application, if we have a lot of records and we want to search for the data that we entered before, we might run into performance problems. If we have like 1 million records and we want to search on different persons by their name, then we might make our life easier and our code execution actually more performant if we have indexing on a database. Or actually our queries will be made more performant, but of course we will always notice these kind of things when running the application. So, indexing is a very basic functionality of almost any kind of database. It basically allows you to say that I have some piece of data inside this particular type of record, or different pieces of data together. I want to find them very quickly whenever I query on them. So that's what indexes are for. And we're going to add an index to this table. And the way we do it is through an update method, because as I refresh the page and the application reloaded, Orchard actually ran this code. And if you take a look at this table here, does it work if I refresh here, please? No, I'm just going to close it to be sure. So Orchard framework data migration record and the top 200. And yeah, it's really nice that that the name starts with a character D, because it's on the top if I order them alphabetically. So as you can see, our data migration class is called Dojo Course 2.module.migrations.person migrations, and it has the version number 1. Why is that? Because if I go to person migrations, the namespace is Dojo Course 2.module.migrations, and the name of the class is person migrations. So that's exactly what is stored here, and it has the version number 1 because I have a create method that was executed just as I refreshed the page and dynamic compilation found it, and it returns the value 1. So if I were to say 100, then this is where it would say 100. I have never ever seen something like that, because we usually start from 1. So, but yeah, 100 update methods should be like a really, really old application, or very, very aggressive release cycle. So how do we update this table? Because right now we have a table. It has this schema. How do we change it? So the way we do it is through update methods, and there's a specific convention as to how you have to name your methods when you are updating your database schema. So the way you do it is very simple to the create method. You say that you are creating a method with the return value integer, type integer, but the name should be update from, and next the number should follow which version we are updating from. So we know that our create method returns the value 1. So if the create method has been executed, then the version of this migration is 1. So we want to update from the version 1. So our name of the method should be update from 1. There are no input parameters here. And this time we should say that we are returning 2. So whenever this executes, the version number will be updated to 2. If I just run the code right now, nothing will happen, just the version number will be updated to 2. But that doesn't really make sense. Okay, so how do we actually add an index to our table? Is very simple. We are going to use schema builder again, and like I said, there are other methods that may be useful. We only care about create table. Now we're going to use alter table. So alter table is, well, the name is quite self-explanatory. So we are going to use the same kind of syntax again. We need to find the table, the same table, so we're going to reference it in the same way, of course. And we also have this Fluent interface again. So how do we do that? We are going to add an index, and the way you do that is by calling the create index method. So simple enough. And when you are creating an index, you need to define the name of the index and also list the names of the columns that you want to include in the index. So that's pretty simple. Let's just call, well, there can be like simple examples. If you say name, it may clash with something else, so you may want to include something else in the, like a prefix in the name. So let's just say that Dojo Course, or actually I'm going to copy paste here. So Dojo Course to that module that person record dot name. So this will fairly consistently and without any clashing identify the index. And what we have to do here is just list the names of the columns that we want to include in the index, and we're just going to say name here. Okay, so now we have this alteration to the table. We have actually added an index to make database queries more performant. And we are quite happy with that. So let's see what happens if I run this. If I open up the logs, you will see that the application is reloaded because the log files are created, but they are empty. And hopefully when the page reloads completely, they will still be empty. Yeah, that's what happened. So if there was some problem with the migration, I would get an error notification here, which you can distinguish by the notification background being red. So it would say that some of the features need to be upgraded by running their migration, and it can't be executed because there's some problem with it. So if you actually fix the code, you can actually manually trigger it, but if the application reloads, all the migrations will be executed. Or actually, it will be, Orchard will attempt to execute them. So, like I said, the log files are empty, which we are quite happy about. And we have our update method with return value 2. So if you take a look at Orchard Framework data migration record again, you will see that our person migrations has the version number 2. So that's really cool. Now we have an index added to our table. I'm not sure if there's a way for us to see the indices, in SQL Toolbox. Anyway, I'm sure you'll believe me. You can try actually if you create like 1 million records or 10 million records and try it without indexing, there will be a difference. Of course, with the examples that we are going to use in this course will not really matter from a performance point of view. But yeah, if you have a lot of data, then this is what you should do. Okay, so the next step would be to actually have some way to store person data in the database. Now we have our table. Now we have some performance optimization, because now we can retrieve information from this table more with a better performance. So let's have some way to actually store and retrieve data. So next thing we're going to do is add a new solution folder, because we like to keep our stuff. Not here, sorry. We like to keep our stuff tidy and well organized. So every different type of class and well, not just classes, but whatever you put in your modules and themes should be categorized. So when you want to find something, you know where to look for. So next folder we're going to create is services. And in the services folder we're going to create a new class, and it's going to be called Person Manager. And I'm sure it doesn't come as a surprise that this is a class to manage persons. So Person Manager is going to be our basically abstraction, our way of abstracting the interaction with the database. One more abstraction layer if however many abstraction layers we have is not enough, but we're going to abstract the management of person objects in the database in a way that we are going to create some methods to store, retrieve, delete, and so on and so forth. So that's what we're going to take a look at next.